So we're going to start the Oceans and Climate unit today. Two goals that we'll focus on for this first lesson is that I can describe the coriolis effect and I can determine the differences between the weather and climate. If you want to follow along using my website, you can go to www.csd.net/groups/chemistry science. So the first thing I want to do is take you to a website called Geography for Kids. The first thing we'll take a look at is the atmosphere. So the atmosphere and the oceans work together to create the climates on Earth. One result of the circulation of gases and particles is the climate on Earth. There's not just one climate for the whole planet, okay? There are several different climates across our planet Earth. And the reason why there are different climates have to deal with the fact that there is unequal heating across the Earth. Okay, there is very hot air that comes from the equator. And it moves either north or south of the equator to create different climates. That warmer air climbs with cooler air and mixes and begins, and that is one way how storms form. That constant mixing of the atmosphere helps to keep the stable system of organisms that live on this planet to survive. We'll go back to the Geography for Kids, and this time we're going to talk about atmospheric circulation. There are both global and local circulations of air around us. Global and local, two important words to kind of know the meaning. Global meaning around the world, worldwide, around Earth. Local meaning more regional, like a certain city, a certain state, maybe the certain side of a country. Scientists have different terms for the circulation based on how large those air movements are. They say macro scale to describe the wind currents that are on a global scale. They use the word mesoscale to describe storms like thunderstorms or blizzards. And lastly, they also use the word microscale for winds that are also small in circulation that may only last for a few seconds. Now, how do these winds occur? What makes air move? Let's talk about the local winds first. Sometimes you're outside of your house and you feel a breeze. These are very fast winds, high in the atmosphere. Sometimes they move hundreds of miles an hour. They're created because there's this unequal heating of the air masses, and that creates winds. So you need to add these things to your notes. That unequal heating and temperature differences also create a pressure difference, and the warmer gases spread out because the molecules need more room. So this unequal heating, it's an important term for you to know during this unit. It explains a lot about how our climates are formed, how ocean currents move, how our air currents move in the atmosphere. We are going to get to, in this unit, we're going to talk about some global winds. Okay, those are the larger winds that push the air around the planet. We have something called trade winds that are one of those. So we have global winds system. We have something called trade winds. We have polar easterlies. And we have prevailing westerlies. Now, we have the planet Earth, okay? Planet Earth, and it's on an axis. Here's our equator. Now, wind is going to be blowing around the Earth. Wind does not blow straight north and south. Okay? It can't do that. The wind, or the Earth is spinning. So the winds that blow in the cells are created by temperature and pressure differences. But because of the spin of the Earth, they cause the winds to move at a curved fashion like this. We used the globe earlier to explain that and how that works. First, we drew a line straight from the North Pole to the South Pole without the Earth spinning, and that line was straight, like this original line that I drew here in red. But once you start spinning that globe and you try to draw a line from north to south, that line is almost going to look like this. It's going to go spinning around the globe. So we've talked about atmosphere and its circulation. Let's talk a little bit about something called the coriolis effect. Based on what we just discussed, you have your rotation of the Earth. Okay? Your Earth is always spinning. Right? And here's your axis. So your Earth is turning and spinning, turning and spinning. And when it turns, your air is going to blow at these curved rotations. Let's take a look. The Coriolis force, we know it as the Coriolis effect, because sometimes the Coriolis force causes a lot of swirling action. It's a force acting on the winds because the Earth is spinning. Objects normally move in a straight line when you're not on a spinning world. However, we are on a spinning world, and if you move in a straight line, you really end up moving in a curved action. So let's write this down. So because of the Coriolis effect, air and ocean currents are moving in these curved directions. So if you look at this picture here, you'll notice none of this wind is moving in a straight line because the Earth is spinning. Air cannot move in this straight line. And that is due to the Coriolis effect. Talk about the difference between weather and climate. Weather is just the state of atmosphere at any time, including things such as temperature, precipitation, air pressure, and cloud cover. It's the daily changes in weather are due to winds and storms. Seasonal changes are due to the Earth rotating around the sun. So when we talk about weather, I want you to think about the fact that this is daily items. When I say items, we're talking about temperature, precipitation, air pressure, and cloud cover. When we talk about climate, we're talking about things that are going to be long-term, collecting data over long periods of time, 30 years at least. And you're going to be collecting data about the temperature, the precipitation, and then you're talking about that region and its climate and what it is over a long period of time. That average pattern of weather. That is climate over 30 years.